Assessing local variables of the enclosing scope. Like local and anonymous classes, lambda expressions can capture variables. They have the same access to local variables of the enclosing scope. However, unlike local and anonymous classes, lambda expressions do not have any shadowing issues. Lambda expressions are lexically scoped. This means that they do not inherit any names from a supertype or introduce a new level of scoping. Declarations in lambda expression are interpreted just as they are in the enclosing environment. So let's use an example to illustrate the point. Okay, here we have the top level class lambda scope test, which have an instance variable called x. Inside it, we have an inner class, first level. It also have an instance variable with the same variable name x. Here we have a method. Inside the method body, we have a lambda expression. We assign this lambda expression to a consumer. Just intentionally, the method's parameter is also called x. So, since lambda expressions didn't create an actual level, the x can be directly accessed inside the lambda expression. And when we call my consumer accept x, this parameter's value is passed in to the lambda expression. So this y is actually stand for the parameter of accept. If accept is here, if accept is 23, the y get value 23. So if we are trying to print out the value of y is actually the value of x. The link is you pass in the x value, the x is supplied into the accept. Accept is parameter is represented by y, and y gets the same value as x all the time. And here is the main. Inside the main, we first create an instance of the top level class. And through the top level class, we get a new keyword, then we instantiate an instance of the inner class. Then we call the method in first level, we pass in a variable 23. So x and y have the same value. Let's run the program. You see, x and y have the same value. They both came down from the caller, and the x is passed to the y. If we want to access variables defined inside the enclosing scope, we need to use this reference. And if we want to reference the value of x in the top level, we need to use a class name followed by this, and then x. This time, x is referenced to the closest scope, which is first level 1, and this x is referenced to the top level x, which is 0. For those two, the rule is the same as local class, and anonymous class. Nothing new. So that's what I print out. One thing to mention is the lambda expression didn't introduce an actual scope. So if a parameter is already defined in the enclosing scope, you cannot use the parameter name again. So if you're trying to say x and you get a compilation error saying lambda expression's parameter x cannot redeclare another local variable defined in an enclosing scope. So as we see, there's no shadowing effect. Like here, you can reuse x because this method is another code scope. This x override shadowing all those x. Here we don't have shadowing effect. This x is exactly the same x as this one. So this is not allowed. We have to use a different variable name, y. And you can use other variable name, doesn't matter, z. So as long as you don't use x, we should be fine. Another rule is the parameter or the local variable defined in the enclosing scope can be assessed inside the lambda expression only when those variables are final or effectively final. So if you trying to change the value of the x, you will get a compilation error. So here the compilation error says local variable x defined in an enclosing scope must be final or effectively final. Since you changed the x's value, it is no longer effectively final, so you cannot use it inside the lambda expression. That's pretty much we need to talk about the assessment of the the lambda scope. It's exactly the same as anonymous class and local class about how to assess their enclosing and the variable defined in their enclosing scope, and also how to reference the instance variables. The only difference is the lambda expression didn't introduce an actual level, so there is no shadowing effect. You cannot reuse the same parameter name. You need to use a different one. That's the only difference between the lambda expression and the local class and the anonymous class. The next topic is about target typing. How do you declare the type of a lambda expression? Recall the lambda expression that selected members who are male and between the age 18 and 25 years. So this is a lambda expression. The lambda expression was used in the following two methods. The print persons. When the print persons expect an interface, we supply this lambda expression. It also be supplied into this parameter. When you expect an interface with type predicate, we send the same lambda expression. So when the Java runtime invokes the method printPersons, it is expecting a data type of checkPerson. So the lambda expression is of this type. However, when the Java runtime invokes the method printPerson with predicate, it's expecting a data type of predicate. So the lambda expression is of this type. The data type that these methods expect is called the target type. To determine the type of a lambda expression, the Java compiler uses a target type of the context or situation in which the lambda expression was found. It follows that you can only use lambda expressions in situations in which the Java compiler can determine the target type. We use the same lambda expression in the place of different interfaces. The compiler have no problem of figure out how to implement the abstract methods defined in those two interfaces, as long as they expect one parameter and return Boolean. The compiler have no problem supply the implementation for check person and predicate. So those lists is good to know. Those places is where you can use the lambda expression. I would say BJP won't test those. So we just skip and target types and method arguments. For method arguments, the Java compiler determines a target type with two other language features, overload resolution and type argument interface. What it says is you can have one method overloaded with different parameter type. Okay, the invoke is overloaded, and since their parameter is different, they are different methods. And if you supply a lambda expression to the overloaded method, the compiler can figure out which overload version you want to call, because with this lambda expression, you basically tell the compiler, I want that method with no input and return something. Okay, and if you look at the invoke, it takes one parameter and returns nothing. So what I ask is that method with no parameter but return something. So the second one is what I want. This one this one takes no parameter and returns me something. Yeah. And the method invoke method runnable. So here is what it says. Will be invoked because that method returns a value. The method invoke runnable does not. In this case, the type of the lambda expression is callable. So this one is used. OCPJP may test, will test this kind of overloaded method. Ask you which one should be called. So in that case, since it's return type, we should immediately select the second one. Serialization will not be covered, so we kind of let's skip it.